Hello people, I left you last video with a bit of a chaotic system. Let me quickly run through it. This being the player, I managed to make the frogs croak if we're close, make them quit croaking if we leave the area, and also quite sillily make them stop when you come closer, so to say. Now, there's a few drawbacks to this system. And that's that it's instantaneous how they start croaking, it's instantaneous when they stop, and it's just not a very elegant system right now. And I had a little thought that might alleviate the problems we have here. So let me stop that. So we have this here croaking thing. This here croaking thing, which is just a big trigger. This is this one that let's see, if you're in the area, it recalculates the swarm presence every half second. If you enter or exit the area, it starts or stops all the croaking here. The check at start here is making a mess of things because I'm working with the disk collider and the actual player, so I'm turning that off anyway. And the problem is really not as much with this system that just enables 1, 2, 3, 4, or 5 of the croak systems when you're in the area, depending on how big the frog swarm is. The problem is really with these single items. These just croak in a loop, so to say. And if I build in something here that will keep track of the player or another target, it should be possible to build a system that more or less does what I have in mind if I move some functionality into the single things here. So, what to do? Again, I didn't really think this one through before I started recording, so bear with me if it takes a bit of work, but the croaking, the triggering system, I'm going to leave as is, so it will check every half seconds if the number of croaks here should increase or decrease. It will remove the fact that this trigger here, this trigger here stops and starts the system. So this can go and this can go, because that's making the thing go a bit weird. I think the thing we need is for this thing here to have an extra component that just handles how the frog sounds in different circumstances. So we're going to leave the random audio on enable here. I think. And what we really need is an extra script. I thought that depends on something like the player position, I guess. You know what? I'm gonna pause this video and think this through a little bit more before I start scripting here, because I'm too vague on what I want to do to make this any useful. I really should think of a good thing to do first. So see you in a bit. Yeah, so what I want to do is build a script here that makes these croaks behave like I want them to. I'm trying to cover that all in a script called random repetitive audio. Let's start filling that in and see where that leads us. So for the croaks, I want to have a number that defines how few or how many croaks should sound out in repetition. So we will build in a public vector2, so we can have a min and a max. Min max repetitions is like a new vector2. Let's say that initially we go between 3 and 5 croaks. Then we will want to have a function that is a delay. And that could also be a vector2. Let's make this a vector2 to add some randomness. Vector2 min max pause is a new vector2 between, let's say, 2 seconds and 5 seconds. And then I want a public float of a chance play chance that is like 0.1 per second, I guess. No, this is silly because I already can do that with a min-max pause, really. Let's imagine that after this and after this we simply start repeating again. So to make this work, I guess we can't do without a coroutine. So enumerator run repetitive play. While true, we run something and then we yield return. Well, we can already return the min-max pause here. You wait for seconds random.range min-max pause x min-max pause y. This is our pause, and then we simply do a for int I is 0, I smaller than. Since we count in 0, we can random range of 3 and 5. These are integers. Smaller than random dot range min max repetition dot x min max repetition dot y and I plus plus. Yes. We'll assume here that the length of the clipper plane in the audio source is enough. There's delay in that for a nice repetition, which sounded like it for the frogs croaking. We can always add an extra value to have an extra pause within this loop here. Int I0, let me think, this should be good. Maybe I need to do it like this for when we're... Yeah, these are floats, so they will never reach actual 5. So this will not make sense. Say it's 3, then it will be not 0, 1, and 2 that it runs. Say it's 5, it will be 0, 1, 2, 3, and 4, which is 5. This is good. Then we shall... Okay, we're assuming here that we also have a random audio on enable here. So we won't try and play something random every time. We'll assume that this will have run on enable and define a croak to play and a pitch to play it at. And then, yeah, I think we can safely assume this. We should really remove this here. We should really remove this here, but let's do that for all of them. This should go, and this should go. This should go. Okay. So we shall say, we haven't defined it yet, but I will define an audio source play. Then we will yield wait until the sound is done playing. Audio.isPlay. Oh, yeah, let's define the audio so we can see what functions it has. Audio source audio is playing equals false. Oh, this should be a lambda function. So we play one shot. We don't call it one shot because we assume that everything is set up correctly. Then we wait until the thing is done playing. Then we play another one. And then, well, this happens and we shall wait for the pause time before we start playing a few repetitions again. Now the behavior here might not be as good as I would like, because I'm imagining that a frog will always sound off 3 croaks or 5 croaks after another. And right now it can do 2 croaks or 3 croaks or 6 croaks and then pause for a random moment. But let's run with this first. So on enable, we will start the coroutine. Run a repetitive play. Okay. And here, let's do that over here. If we haven't found our audio source yet, then let's find it. Audio is like gets component audio shortche. This happens when we enable. I think we will also need to change the random audio on enable script here. Okay, yes, we've compiled, so this one can go over here. Oh, come on, you can do it. There we go. We don't enforce play here. So we use the random audio on enable simply to fill in the various pitch and clip settings. So every time we're enabled, we have a different clip and a different pitch. And then we shall just run through this script. This should already make it a bit better. Let's see. Okay. This is weird. Okay, that's because the Swarm Presence audio doesn't disable all these things at start, which it really should. So we enter. We have now 2 of these sources present, and each of them has a certain number of croaks it plays before it pauses. Yeah, this is good. This is nice. This is already nicer than what we had. And I believe that when they splash... I think that I should also enable that once they have jumped, that we turn down the estimation of how big the swarm is. I like it. Okay, that's step 1. Let's define some better values here, because let's do like 2 and 4. And let's have a pause between 2 and 12 seconds. I don't know, 10. Okay. And let's go to the swarm. Where is my thing? Where is my thing? The frog manager. Because what happens now is that when the frogs jump into the water and disable themselves, the frogs manager here doesn't know about it. So what we should really do is tell the frog, let me get the frog, where are you? Over here. We should tell the frog, yeah, open the script, thank you, that if it has a manager, let's see, a frogs manager in this case, because let me rephrase what happens. Where is it? The frogs hash set here does not get updated when one of the frogs disables itself. See, it gets added to here when we are running a single frog spawn, which is good. It gets cleared here. And here there are frogs removed because we check if they're disabled or not when the player is leaving. So that should change. Let me see. This can go. I shall remove this. What we're going to do is see if we are a child of a frogs manager. Because the frog jumps out of its own accord, it will signal the manager, if it can find one, that it should stop croaking, so to say. Let me think. Where do we initialize this? Because I could obviously do that over here on disable. Because this is what's called when we jump into the water. And this is when we need a manager. So for now, we'll just do that over here. If not manager, then manager equals get component in parent. Oh, frogs manager. Really, this should be run on awake. Come on. And then here we can do an if we have a manager, we will signal the manager dot remove this one, remove ourselves from the list. Now the manager needs to have a remove function. Where shall we put that? I think spawn single frog is not a public function, so that should actually go like here. We have players entering, clear spawn frog. This one, if all is well, doesn't get run. Clean spawn frogs. We'll leave them here, but we shouldn't be using them. We should just be using the players leaving and players entering. So, well, that's for another time to decide. Let's see, let's do that over here. Public void remove. Oh, jumping frog. And all that has to do is this for now. Frogs.remove frog. In which case the count goes down, the estimation changes, everything should actually work if we just remove ourselves from that hash set here. Okay. Where were we? We did this so the swamp presence audio and the random repetitive audio don't keep playing because they get disabled, I guess. And what we had to do still is run this on start. Yeah. Wait, start. Disable audio. We will change the names here because it's much more general than just the audio. Let's just do that right now. Swarm presence elements. Let's call it this. Swarm presence elements. Save. Let's immediately change it in here. Where is it? Swarm presence audio will change into swarm presence. Hello? Yes, swarm presence elements. Double compile. Open this up. This one has disappeared. And then we will call this update presence. And we will call this enable presence. And we'll call this disable presence. Like this. And we need to fix it up in here. because the trigger here now calls non-existent functions after compile. The trigger here that runs every 0.5 seconds if the player is inside should run now update presence, which recalculates the number of frogs that should be enabled as in here. And this trigger should now on enter enable presence, and when the player leaves it should disable presence. And I think we already removed it from here, right? Yes. Okay, let's see what that asks. So this is good. Nothing here because we're not in the area. We move into the area. Just listening to the beautiful sounds. Hmm. 3 times. Nice. They're really talking. Cool. They're actually talking. So when we move closer, we can see them. And when we make them jump into the water, the sound stops. Very good, very good. This is odd. Why is there still something sounding right now? This shouldn't happen. Oh, I know what happens. This is because the frog manager keeps track of the last time the player left, and this doesn't get reset every frame. So the virtual frog count will keep increasing because this doesn't get reset to the current time. We only set it to current time here when we're entering. We set it to the current time here when the player is leaving, which is a good thing. And we set it at the current time at start. How do we do this? Because we want to prevent this value from growing ever larger, even if the player is actually present. I don't think there's any other way to do this than a not super elegant way, but to just track a boolean. Player is present is false, and then set that here. Player is present is true, and then this is not interesting, but here the player is leaving, so let's do it like this. That should be good and enough. Start, and then we can't help but run this during update. So, oh well. If the player is present, then we is present, then the player left time. No, it's something with time. Time player left equals time dot time, like this. Yes. This is not really elegant, because now we have an update function which runs every frame, but really, this isn't too much code to run. So now we prevent that the virtual frog count goes up when the player is in the area, which is a good thing. Okay, let's test it out. Okay, so we can hear one frog, which pauses and does a few repetitions. Should start again. Yes. Very good. At a certain point, a second frog should join in, because we're not in the area right now. If we were in the area, we would see the little lines of the frog jumps here. Where is my next frog? Oh, we are actually in the area. Okay, we shouldn't be. We should be here. Then the frog count will start increasing, and we'll still hear it because we're here. Oh, that was the reason we didn't see the lines here, because we hadn't the frog thing selected. So now there's two sound sources, while there's actually, well, there are no frogs, but there should be. Should be like 6 frogs or so. There we go. 7, no, 6 frogs. And we make them jump, and the sound should stop, but that last frog refuses to jump. Huh, don't you see me? I'm like the player. If I, there you go. There's still a looping croak active. Mathematically, that's not correct, but it's not really a problem here, because there could be a frog hidden, I guess. But I have to figure out why this one is still here. Because player is present, so we should actually I think this is because this doesn't work. Imagine that presence is at 0. And count, yeah, I think we should have this. If count is at 0 and presence is at 0, then we still have one active object, which is something that shouldn't happen. So let's try this one. But then I betcha I will never reach the 5 croaks. Let's see. This is correct, because there's one. Cool. Now there's no frog anymore. Let's increase the spawning rate. There we go. All 5. Very good. back to 10. Jump in, silence, and we move away. And I'm not sure if we're still in the presence area. Yes, we are. So a second voice will come in. Cool. I like it. Now, there's a few problems still, and I could illustrate that by just moving out of the area. Did you see? The voices simply stop instantly. We don't really like that. I don't know if it's really a problem, to be honest, because these voices here... Oh, we're still on debug mode. Yeah, the max distance here is at 20 meters. And what we could do is just decrease this to 5. Then we won't even hear them if they're there. Let's measure it out. So let's do it like 7 meters. Let's pick them all. Like here. That should mean that we won't actually hear them when we're further away than that. And that should mean that it won't be irritating that they suddenly stop playing if the player leaves the area like this. Oh, what's happening, Unity? Okay, I lost focus for a moment. Okay. So that's an easy fix, really. This will make them a lot softer, but that is not necessarily a bad thing because they were pretty loud. Let's see. This is kind of nice. Okay, the fact that they stop right now, seem to stop, is because my camera is actually over here, so I'm hearing from here. We'll test that out in a bit. Now, let me check on the time. This is already half an hour in, which is really long enough for a single video. So I'll keep it at this right now. And in the next one, I'll handle what happens if the player comes closer, because that's now a bit odd. I mean, you come over here, they keep croaking and then jumping, and then their voices suddenly stop. We don't want that. So we should build something in for that. Could be a simple, short one. I don't know. We'll see. I'll leave it at this for now. Bye-bye.